Questions concerning the relationship between tasks and the resulting timing are always easier to do when you draw a picture. This problem is an excellent example of that. Task C has two immediate followers, task D and E. Might as well draw this. Task C, that represents C, has two immediate followers. Okay, this one will be D, comes after. This one will be E, comes after. What else? Task C has a late start time of 10. See, now that we have this framework, we have somewhere to store this information. Task D has a late start time of 10. That belongs right here. In our table, the lower row for late start, late finish, 10, it's a start. And then task E has a late start time of 8. That belongs right there. Now, finally, actually, what's the question? What is the late finish time of C? Oh, this question is an opportunity to practice the late finish time rule. We need to remember that the late finish time of an activity is always equal to the smallest of all the late start times that follow it. The late finish time of an activity, that's right, we're looking for this number right here, is equal to the smallest of the late start times that follow it. So the answer to this question is 8, because between 10 and 8, 8 is the smallest. What might help to remember this is to just picture it. We were trying to figure out what's the latest that this task could finish and not create any delays. What the 10 and the 8 over here mean is that D has to start at the latest in 10 days and E has to start at the latest in 8. And we don't want to create any delays. Both waiting on this one, right, that's why you would have to pick the smallest one and pass it back. Now the next question is another opportunity to sketch. Task C has two immediate followers, task D and E. Task D has a late start time of 10. But does this sound familiar? This is actually the same diagram that we just drew. So I'm a little lazy, but I'm going to use the diagram that we just drew. I need to pay attention though because some more information's been supplied. In this question it says task C is 2 days long. That does belong on the diagram right there. And then what is being asked in this question? What is the late start time for task C? The late start time, oh, right here. So to answer this question, we remember this relationship. It's just logic. A late start time equals a late finish time minus the task time. I'm just going to write a little lowercase t. In that we know that it has to finish in 8, 8 minus 2. All right, we're backing up in time. It needs to start at the latest in 6 days. So up here, the answer was 8 days. Down here, the answer is 6 days for the 8 minus the 2. Now, the next question, oh, wait a minute, the next question doesn't refer to this network that I had drawn. Let's take a look at it. Task E has an early start time of 3. Maybe I should write this down. Early start time of 3 and an early finish time of 5. Okay. It must be 2 days long. While it has a late start time of 10 and a late finish time of 12. What's the question? What is the slack in activity E? Oh, that's easy. We remember that slack, there's 2 ways to calculate it. You could take the late finish time and subtract out the early finish time, or you could take the late start time and subtract out the early start time. It doesn't matter. Slack is essentially the difference in the 2 sets of timing for any task. So for this particular problem, this task E, you could say 10 minus 3, that would be 7. Or you could say 12 minus 5, that would be 7. The slack in task E is 7 days. Either way, you should get the same answer. If you're ever doing this type of analysis on a network and for some certain task that wouldn't yield the same answer, it tells you that you made a mistake somewhere in your calculations. You can choose between either, they'll always get you the same answer.